In this video, we're going to take a look at water and some of the unique properties and principles of water, and really why it's such an amazing substance and how it allows life to really function on our planet. A couple of probably obvious things about water. One, water is liquid at most temperatures. So at most temperatures that you're going to experience, water is liquid. When it freezes, when water gets cold enough, it actually will float. And this is caused because ice, the solid form of water, is less dense than the liquid form of water, and so it allows it to float. And this is actually a very important and unique property of the substance, and really allows life to survive. And if ice didn't float, we'd have some problems on the planet. Let's first take a look at the structure of water. The structure of water is made up of H2O. 2 hydrogens and 1 oxygen atom. If you look at our image over here, you maybe will notice this looks very similar to something that you maybe have seen in childhood. Maybe you've gone to the amusement parks. If you rotate this picture a little bit, it kind of looks like Mickey Mouse. Here's the face. You've got 2 ears. That's the structure of water. Water is made up of these 2 hydrogen atoms and this 1 oxygen atom. And the way that these molecules bond together, that these 2 hydrogen atoms and oxygen atoms bond together, is that oxygen wants to have a complete outer ring of electrons, and it wants to have 8 total. 1, 2, 3, 4, 5, 6, 7, 8. Normally it only has 6 in its outer ring, and so it forms some covalent bonds with hydrogen. And so hydrogen is sharing its electron with oxygen. Oxygen shares its electron with hydrogen. And because of that, these 3 molecules bond together, and so we get a water molecule. Now, I said that oxygen kind of shares its electron. Oxygen has a higher or a greater electronegativity. It has more of a negative charge, let's say. And so because of that, it's kind of pulling those electrons more towards itself and away from those hydrogens. So it's kind of hogging those electrons a little bit. And because of that, oxygen overall in this water molecule has a slightly negative charge, and hydrogen has a slightly positive charge. So these 2 hydrogen atoms here have a slightly positive charge. The oxygen has a slightly negative charge. And this unequal distribution of charges we call a polar molecule. It makes this molecule polar because the oxygen is slightly negative, the 2 hydrogens are slightly positive. It's not evenly balanced between the 2. And because of this, and really one of the most important things about water, is because of this unequal balance of charges, because water molecule is a polar molecule, we get these things occurring called hydrogen bonds. And we've previously talked about these a little bit, but now we're really going to take a look and see how these work. So the way that a hydrogen bond works is it's between two different water molecules. This would be number 1, and let's say this is number 2 over here. I'm going to use green so that we can actually see this. And a hydrogen bond is going to occur between these 2 different water molecules. And so here is our hydrogen, right at H right here. This is the hydrogen of our first water molecule. And over here we've got our negative oxygen. Here's our oxygen. And so as we said, the oxygen has this negative charge because those electrons are kind of congregating or pulled more towards that oxygen atom, and so the oxygen has a negative charge. The hydrogen thus has a slightly positive charge. And so between these 2 different molecules of water, we get this kind of attraction. You've probably heard the term opposites attract. And so between this positive hydrogen of one water molecule and the negative oxygen of a second water molecule, this attraction causes a hydrogen bond. And so they kind of tend to stick together. The actual molecules are sticking together. And this is really unique because then it allows a bunch of water molecules to stick together. You think about a water molecule, this oxygen is now bonded to another water molecule, but then we also still have these 2 hydrogens over here that can also bond to 2 other water molecules. And so because of that, these water molecules can stick to a whole bunch of other water molecules, and then you get this huge collection of water. And that's what allows water to stick together, is hydrogen bonds. Something else that we need to discuss, we want to look at with water, the temperature or the conditions of water can change or can differ very much. And one way that we can measure that is something called pH, which stands for the potential hydrogen. And with this, we're looking at acids and bases. And an acid is really a compound that's going to release a proton when dissolved in water. That would be like if you add this compound to water, it's going to give off hydrogens. It's going to release hydrogens. A base is a compound that removes a proton when dissolved in water, so it's going to take in hydrogens. And we can use something called a pH scale to measure this, to measure the acidity and the basic levels of different substances. And this is on a scale of 0 to 14. Something that's in a range of 1 to 6 we would call acidic. It's an acid. 1 being the most acidic and 6 being a very slight acid. On the opposite of that, 8 to 14 is basic, and so 14 is going to be the most basic, and 8 is not very strong of a base. So the farther away from, you probably noticed this, 7, the farther away you move from 7, the more acidic or more basic it's going to be. And let me show that here. Let's say we've got a number line, and let's say right here is 7. And 7 is neutral. 7 is neutral on this end. Let's say this is a 1 down here. Let's say this is 14. The farther we move away from 7, the more basic it's going to become, or the more acidic or acid it's going to become. And so a 1 is going to be very acidic, 14 is going to be very basic. Now, we're going to discuss this in class, next class together, but I'd like you to think about this. Water is very polar and able to form hydrogen bonds with other water molecules. Why might this be important to life? Think about this. We'll come back to this question in our previous class, or in our next class. A couple properties of water that we want to take a look at. Hydrogen bonding we already talked about. Attraction between positive hydrogen atom of one water molecule and the negative oxygen atom of another water molecule. This is a pretty weak bond in comparison to covalent bonds. It's not as strong as covalent bonds, but it does allow water molecules to connect to one another. A couple properties that might be a little bit new to you, maybe you've heard of them before. The first one being cohesion. And cohesion is the attraction of a molecule to the same particle or the same type of material. And this is really water being attracted to other water molecules. And this can happen with materials besides water. But this is the attraction between two similar substances or molecules. Adhesion is kind of the opposite of this. And in adhesion, we're attracting one molecule to another type of particle or material. For example, water being attracted to the graduate cylinder surface. If you pour water into a graduated cylinder in order to measure it, it's going to be attracted to that surface, and so it causes that meniscus, that kind of dip that you see in the graduated cylinder. And what's really cool about this is one of the reasons and one of the properties of why water is able to kind of defy gravity and to move up plant roots and limbs. Can actually move up tall plants, tall trees, because that water has to get to all the different branches and all the different levels of the trees. Surface tension is another property, and this one is a liquid surface resisting an external force. And so sometimes the surface of a liquid can actually resist an external force. A good example of this would be like the little water striders or water spiders that you maybe have seen that kind of skim across the surface of water. That water is resisting the external force of those water spiders, of those bugs. And it also allows some materials to float rather than to sink. And the last one, and I think one of the most important, well, they're all important, but I think one of the most important is the moderation of temperature. Water requires lots and lots of energy to change temperatures. To get really warm, to increase in temperature, to decrease in temperature, it requires lots of energy. And so really water helps to regulate the climate, specifically the temperature in regions near large bodies of water. You think about the ocean. Usually between the summer and the winter, it doesn't change temperature generally that much. I mean, there's going to be some changes, but there's not going to be a huge change in temperature as there is on the land. Well, the same thing kind of applies on the coast. You think about if you've ever gone to the Oregon coast, the beach, it gets pretty cold in the winter and it can get warm in the summer, but not as much as it's going to more inland. You think about cities in the Midwest, like Nebraska, Omaha, for example. Omaha is kind of in the middle of the country. It's not surrounded by a large body of water, and so in the winter it gets extremely cold, and in the summer it gets extremely hot. You compare that to somewhere on the coast, let's say Coos Bay in Oregon, for example. In the summer, it gets pretty warm, maybe 80 degrees, maybe 85 on a really, really hot day. In the summer, it might snow like once in every 10 years, but really it doesn't get that cold, maybe 40 degrees, 35 degrees. And so because Coos Bay is close to the water, and because Omaha is really in the middle of the country and it's not surrounded by any water, and because of this fact that lots of energy is needed to change that water temperature, the ocean close that Coos Bay is located by is helping to stabilize that temperature, whereas Omaha doesn't have that large body of water to help stabilize the temperature, and so it has big changes in temperature. The changes are very extreme. Those are the couple of different properties of water. We'll look at these a little bit more closely in class and in lab, and really discuss these a little bit further with some of the reasons why water is so important to life on our planet.